finding errors before we could deliver it to the end user. Yeah. So what testing shows? What are all the things our testing will show you? So it may show you some errors and it may show you some requirements, conformance. Like we start with the requirements. We document the requirements. What are all the requirements from the software? So whether it goes along with that or not, that also will be shown through your testing. And then performance, how good your software performs. So we make the software with some intention. Okay. So suppose if it is taking too long to give the output, it is taking too long, or by any means it is occupying more space in your mobile phone, or you are generating some mobile app. When you are downloading it, it occupies more space, due to which you are not able to do anything else. Normal browsing or even making calls or some other mandatory purpose also getting affected by this now. Of course, it cannot be accepted. So the performance of a particular software will be checked through the testing, and indication of quality, how good it is. Like when there are two similar products, you will be able to compare one with the other one, again based on the performance only. So performance determines the quality of a particular product. Okay, so performance may be in any aspect you can take, how fast it works, how convenient it is, how it is user friendly. Quality means whether it will go for a longer duration, it will be long lasting, or I can use it only for a few time, or it may crash the entire system itself, or that itself may get crashed. Like those things can be tested, can be the output of the testing. Strategic approach. What could be the strategic approach of a testing? To perform effective testing, you should conduct effective technical reviews. Just like that, you do something, you yourself will be testing now. Obviously, you will not be able to find out the error. Correct? Most of the time, we also do the evaluation, and at the same time, experts, a technical team should test the software. Only then you get the real feedback. So it must be tested by a technical team. By doing this, many errors will be eliminated before testing commences. So first there must be a review, and then only the proper test will be taken place. So while doing the review itself, like it is like, you are writing the exam and you are submitting, then we do correction, we find the mistakes in it, accordingly we reduce mark, and if there is no much mistakes, we give good marks. But always we insist from your childhood itself, before you could submit your answer sheet, you need to go through once and then submit, because you yourself will be able to identify the mistakes in it. That is what is done by the technical review. So before it is undergoing testing, the technical team will be testing it, and if there is any minor errors or anything could be corrected easily, that will be done. Later only it will be passed to the real test cases or testing team. Testing begins at the component level and works outward toward the integration of the entire computer based system. So component level, unit level, a small module level test. You start the testing only from the module level or unit level, and then it goes towards the system level. So when you see the hierarchy of the testing, it will be of unit testing, integration testing, and then system testing. So unit testing starts with only a component level. Like you are having some 4 blocks. So first block will be tested. When it goes well, when it is perfectly alright only, you merge that with the other module. So once you merge 2 modules, then it has to be undergone integration testing. So you start with the component level and goes towards the system. Like when you integrate everything, finally what the system here, the whole system will be undergoing a testing called system testing. Clear this? So these are the strategies. Different testing techniques are appropriate for different software engineering approaches and different points in time. Like for all software, are we following the same strategy? Same testing is applicable? It is not like that. Depending upon for what purpose the software is developed, how which are the technology we are using to develop the software. So to which purpose the software is developed, based on that what kind of may get changed too. But anyway, everything comes under unit, integration and system. Okay, fine. Testing is conducted by the developer of the software and an independent test group. So there may be two kind of people may test the software. One, the developer, that is self-testing. A team of people are developing a software. They themselves will be doing a testing. What type of testing it is? The developer testing, unit testing. So unit test, because they are the one who will be developing that particular unit or the module or the component, they will be doing a test. Later, once it is completed, it may be tested by an expert team or it may be given to the user. It may be of anything. That's the reason the second category comes under common different independent test group. They are nowhere connected with you or they may be close to you. It may be of anything that we saw, right? Alpha testing, beta testing and all that. Fine. Testing and debugging are different activities. Please try to understand, because debugging is the second half of unit 4. Testing is one kind of activity. Debugging is another kind. Test will only test. Debug will correct the errors. Debug will diagnose the error, right? So testing and debugging are different activities, but debugging must be accommodated in any testing strategy. Unless and otherwise you complete testing, you cannot debug it. Correct? You find out the error and then rectify the error. Finding out the error is done by testing. Rectification of the error will be done by debugging. As simple as that. So the points are clear? Yes. So this V and V are very, very important, which was explained even in the last class. Verification and validation. So these two are like a formula or very important slogan for the software testing. Any testing will be having verification and validation. If you want, you can switch on the fan. Verification refers to the set of tasks that ensure that software correctly implements a specific function. Software correctly implements a specific function. So there is a function. Okay. So my software should do this particular function. My software should do this particular function is the verification. You are designing a vehicle. Okay. So the purpose of the vehicle is to move from one place to another place. Okay. So you are doing something which has been intended to do a particular function. Whether it is able to do it or not. I am saying that I am designing or leave it. I am designing a vehicle which will be able to carry 1 ton of weight. 1 ton of weight. So I put 1 ton weight over there. It is not able to move. So the function what I have assigned is my vehicle will be able to carry 1 ton of anything. But when I put 1 ton of weight over there, it is not moving. So in the verification, it fails. So verification is checking for what purpose it is being designed, whether it is able to meet that. Validation refers to a different set of tasks that ensure that software has been built is traceable to customer requirement. Like you are releasing, you are launching the software that has been, you have said that could be used by all the people who are in that community. But to certain group of people are able to use, certain other group of people are not able to use it. It meets the functional requirement but not by all the people. That is validation. In simple manner I explained you in the last class, we check with various set of data. It may work with one set of data, it may not work with some other set of data, but it should work with all the set of data. That will be determined by the validation. So verification whether the function is done, you are able to do it or not. Validation, you are able to trace with various set of input. That is about validation. So like the slogan this you can remember, verification, are we building the product right? The second thing is, are we building the right product? As simple as that. Okay. So if you are not able to remember that, please remember the examples what I gave you. Okay. It may work well and sometimes whatever you plan to get the output you don't get, but you get some other output. Then verification fails. Verification fails. Validation. You are getting output for one set of data. When I give some other set of data, it is not working. Okay. Say you have written a program to find out a number is palindrome or not. When you give only 3 digits, it goes well. When you are giving some 5-digit number, it is not working out. Okay, so I cannot just stick on to only a 3-digit number, but it goes well with the 3-digit number. Validation fails here. It should work for all set of data. Fine. Who tests the software? This is what we just saw in the previous thing. Developer understands the system but will test gently and is driven by delivery. So a developer who is developing the software, because he is the one who will be knowing about the software. He is told what to do. He is told, he is instructed what to do, for what purpose the software is getting developed. So he will be able to test. So developer who is developing the product will be checking, testing the product. So that we say developer. Independent user may be of anybody, must learn about the system but will attempt to break it and is driven by the quality. So this is the other team. They are nowhere connected to this. They may be experts. They did not work in this, but they know the technology. They know the requirement and they know what must be the output. With that they may check, or it may be the user, because user only have given the requirement, developer has developed it, they will be able to check whether I am able to use it or not. So it may be of any group, any independent group may test the software. So this is also an important thing, who can test your software. Testing strategy. Testing strategy. So system engineering, analysis modeling, design modeling, code generation. When the code is getting generated only, we start testing. So when the code is getting generated, a small level, a module level, immediately we do the unit testing. So we can say that after the code generation, we start expanding it, unit generation. Then you are, according to your design, what you have made, you are connecting one module with the other module. When you connect the two modules, obviously it has to be undergone by the integration testing. That's why in the outer circle you can see this integration testing. You keep on integrate the modules. And as and when you add one module to the existing modules, you need to perform integration testing. So finally, when it becomes a complete system, when it becomes a system engineering, then we do validation test. That is nothing but system test. On the whole, the system is tested. So with this diagram, if you remember, it will be easy for you to remember forever. So testing strategy. Yeah. So what could be the testing strategy? There are two strategies we follow. We begin by testing in the small, that is a module level, that is a unit testing, and move toward testing in the large. We go till the system testing. Correct? So from the unit testing till the system testing we will be doing. So for conventional software, if it is a conventional software, traditional software, what we do? The module is our initial focus. If it is just a simple kind of, there is no object oriented concepts is over. Like always we say conventional or traditional is a top down approach. Your procedure oriented languages. Like if the software is being developed by using C language, we go with the module, like module only will be the main focus. And integration of modules after that only will come. Whereas when you go with the object oriented software, if it is designed or developed by C++ or Java kind of programming languages we are using now, our focus and testing in the small changes from an individual module to an OO class that encompasses attributes. Like there we start with the object. So class is just an abstract type only. Unless and otherwise you create an object for that, your class will be just dumb only. Correct? You need to create an object. Through the object only, you will be able to access the attributes of your class, member or member function, whoever it may be, who are sitting within the class can be enabled only by the object. So there we go with the object only. Whatever the changes you make over here, it will affect even the module. Okay, so the first one, module is the focus. The second one, it is a bottom up approach. So there we don't say it is a module by module we can do. That's not possible. Okay. Strategic issues, this and all not necessary. You go with the unit testing diagram. So when that picture and all, whatever you want you draw. But in unit testing, as software engineer, module to be tested because software engineer is developing a module and the module will be tested. The result will be proposed. We will be following some test cases. Some certain test cases will be used to do unit testing. So who is testing? Software engineer. The one who is developing the software, he himself will be able to test the module, component, unit testing. Yeah. So unit testing, module to be tested. What are all the things we test here? My test case will be framed. I design a test case to do test on my module. So what are all the things we will be testing? Local data structure, boundary conditions, independent path and error handling path. Error handling, I hope you are learning now in OOPS, right? So error handling and all, exception handling, those things are like within a module. These are all the things focused on the unit testing. So when the test case is designed, when the test is planned, all these things will be included. These are all the things have to be tested. Unit test environment, how the unit test environment will look like. So this thing and all you are familiar, module, and the module will be having some smaller kind of compartment, stubs we say. So then our test cases will be testing the entire unit. Just for more clarity only these diagrams are given. Once you understand the concept, that's it. Integration testing. The options are the Big Bang approach and incremental construction strategy. But once you look at like this kind of game only, right? So you fix one thing and then when you have puzzle, this kind of puzzle if you have experienced in playing, when you take the second one itself, you will see the apt place, or when you put it over there, then you will see whether you are able to accommodate the next piece of it. Okay, so every now and then you test and then only you proceed. Just like that, you will not throw over there. Finally, you will not break your mind. You get my point? So as and when you try to fix one block, you will check the right portion. So you fix it and you see the compatibility of it, only then you will proceed. That is what is nothing but integration testing. So this is the technical point of view. Top-down integration. So the integration will be of two types. What are all the two types? Gautam. What are all the two types of integration testing?
Top-down integration.
Default? No. Top-down integration, when it comes automatically bottom-up integration and default integration. Okay, so top-down integration, and normally we follow with the top-down integration only. So top module is tested. That is the very first module. Very first module will be tested, and if there is any connection with that, that also will be tested. Steps are replaced one at a time. Depth first. Like you are going to connect. It is like you will be assuming that after that there may be number of modules will be joined with that. Then when the new module comes, you replace it with the new module and go on do that. As and when you add one module with that, again you have to integrate it and check, rerun the test. Once I connect the second module with that, how it goes well, whether it is working good or not. So every time the test will be performed again and again. Okay? What we show? So this is bottom up integration. Bottom up integration. So this will be performed anyway. The main module will be there. You connect all that, and then from the last it is exactly used for your object oriented programming, because though the class is defined or a number of classes are defined, or you have created inherited classes and all, you have established parent child relationship, whatever it may be, unless and otherwise you create an object, all these classes will be idle. So you create an object to which class you are creating, only those two things will be enabled, and then from there you may be traveling towards up. That is why we say it is a bottom up. So from the cluster and then you move up. Sandwich testing. You combine both of them, top down as well as bottom up approach. We say it is a sandwich testing. So this is the term you need to remember. So we have top down approach and bottom up approach. When we combine somewhere, like first two levels I may use top down approach, then rest of the levels I may use bottom up approach. When I combine both the approaches, Kamalesh, when we combine both the approaches, what is the name of testing? Kamalesh, I think all are not Kamaleshwar. Yes, now Bharat, pass this ma. Get up ma. Read the regression testing and explain. So we do, as I mentioned, testing and debugging are interconnected. We do testing, and if there is any errors found, mistakes found, faults found, we make a correction over there. We do debugging and all. After the debug, after you make some improvisation, after you make some corrections in the existing software, once again you have to test it. When you make a correction, just like that we cannot do it. Once again you have to do the unit testing as well as integration testing. So that is what is called regression testing. You are checking the progress of it. After the changes, whether it has created any defects, it is going well, or it is creating any side effect, all those things we need to do it. Sometimes it happens. There may be a minor error. When we try to correct, it may lead some other errors. So those things have to be done by the regression testing. The whole paragraph says that only regression testing helps to ensure that changes do not introduce unintended behavior or additional errors. Exactly. Suppose you are not very familiar with your C programming, or your seniors or other people and all, normally how it will happen? No, they'll be writing the program, typing the program. They'll try to compile it. They'll get one or two errors. They will call us. When we are correcting that error, we will be going according to the flow only. So the first or second line itself, there is a syntax error. We try to correct and compile it. It will show some 40 errors. And this fellow will be showing long face. So you ma'am, that time we had only 2 errors. Now you have brought it to 40 errors. It is like when we do something, whether it is going, but that particular case is a genuine case. Somewhere else also there may be an error. One error, if I correct, all the errors also may be vanished. But normally when we try to make some changes in a program, whether it is creating any other error, when I am deleting a function call in the main, obviously on the other side the function cannot be called at all. Okay, when I delete a particular module in the program, and here if I introduce a function call, obviously the function cannot be called. When there is a dependency between two modules, and if I try to make some changes in one, it will affect the other module. So that also needs to be checked. That's the reason whenever you debug your program, you make correction in your program, again and again you have to compile and execute. Are we all doing that? We are doing, right? So we see, we compile it, we found some errors, and then immediately do the correction, compile, execute. That is what? Simpler manner, regression testing. So next comes to smoke testing. So these are all some additional only. So main testing and all we have completed. A common approach for creating daily builds for product software. Smoke testing steps. Software components are being translated into code or integrated into a build. That's what. This is not applicable for all the cases, and it is not in your syllabus to let us skip this. Just to know, object oriented testing, again these things are not there in your syllabus, but still just go through the OO testing alone. What is object oriented testing? Begins by evaluating the correctness and consistency of the analysis and design models. So first we do analyze the cases and then only we go for correcting the errors. That is adanalada object oriented is a bottom up approach. So for this object, whether there is any connection for the class, or if I make some changes on the object, what are all the consequences by other classes, those things and all will be tested by object oriented testing. It is purely about the object based testing. Web testing, just go through panika. So let me move to debugging, the second half of the unit. So debugging, in simpler word I can say a diagnostic process. Diagnostic process. Okay. So the debugging process can be depicted like this. So you have a test case. Okay. So test case is producing the results. Ungaloda last class on the diagram pathina, starting with the process, test plan, undergo testing, finally it will generate a test report only. So that is what is given here. Test cases will create a result. Test report will be generated and that will be undergoing debugging, because when I understood this is the problem with my software, obviously we need to do debugging. Summa test mattu pannittu thooki potu irundha, once again we cannot recreate the software. We only make the corrections and then work it again. So do the debugging. So the debugging again, after the debugging it may go on to different way. One is suspected causes, additional test, and then again it will undergo test cases. So only somewhere only there is a fault, that alone we concentrate and then proceed with the test cases. Another thing identified, we are very sure about some cases they are only wrong, and then corrections, regression test, and then go with the test cases. After the regression test also go along with all the test cases, produce the result. So this is very important. This diagram is very important. Anyway, I am going to share all this to you. You can see that debugging effort. So what are the effort you need to put for debugging? These are all simple thing only. Time required to correct the error and conduct the regression test. Time required to diagnose the symptom and determine the cause. These two things will. One to diagnose and debug it. Okay. Next you need to find out, like when some symptom comes, like nammaloda health paathukonga, whenever we get cold we will be alert. I may get fever also. Whenever we get some symptom, we will come to know this is what is going to be the problem. Not only for us. உங்க வீட்ல உள்ள ஒரு ஃபேன் வந்து சுத்தும் போது அதுல சவுண்ட் வர ஆரம்பிச்சு அப்படினாலே இன்னும் கொஞ்ச நாள்ல it is going to be repaired. So I have to see that you are using the water tap. Okay, so when the water gets reduced only you come to know that water got over in the tank, so I have to switch on the motor. Correct. In the similar way, when I understand the symptom of a particular error, that is possible to debug easily. So that needs to be done always. Okay, so unga phone la recharge பண்ணனும் அப்படினா you get frequently SMS. Okay, so immediately you will decide that few days before itself you will start getting the SMS where all the symptoms that your validity gets expired. Similarly, when you are using more data, நமக்கு ஒரு indication வந்துட்டே இருக்கும், இவ்ளோ data over, இவ்ளோ GB over, right? So like that, when you are working with some software, you get some symptoms. Based on the symptoms, you should test, debug and proceed further. So for both the things you need to allot the time. This comes under project maintenance. Testing is one half, the second half is project maintenance. Okay, right. Symptoms and causes. என்னென்னலாம் இருக்கலாம்? Symptom and cause may be geographically separated. Geographically may be separated, but both are together only. They come together only. Symptom may disappear when another problem is fixed. Sometimes you fix some other problem, this will be vanished. Okay, it happens so. You correct one error, other error also will be vanished. Cause may be due to combination of non-errors. Okay, so cause may happen due to combination of various non-errors too. Cause may be due to a system or compiler error. Compiler error in which you may not get the output. Your logic may be correct. Everything is correct. But when you are compiling it, it is not working out. You are getting lot of error. That may be due to compiler error. Mainly syntax tappana. Mainly syntax tapparanja. So syntax is wrong, logic is correct. So again you may have the problem. Cause may be due to assumptions that everyone believes. Many times we feel so, right? For something, due to this only it is happening. I am getting error. So if I change this, that may get corrected. Due to some of our own assumptions also, it causes the error. Symptom may be intermittent. Debugging techniques. So this alone you please go through. There are various techniques to debug. Number one, brute force or testing. What do you mean by brute force? Straightforward approach. Straightforward approach. So whenever there is a problem in my program, it may be somewhat around 20 lines of coding only, I am not getting the output. There is no compiler error, compile time error, but I am not getting the output. What normally we do? We start checking from the line 1. From into main onwards, we will start checking it. That is the brute force attack, brute force approach, straightforward approach. I don't know the reason why there is an error. I will just start tracing from line by line. Anytime it happens, right? Even when you are solving a problem in mathematics also, when you are not getting the answer, again what do? We will start from first line. Okay, that is brute force. Backtracking. Sometimes some problem from the bottom we will go through. From the answer where you are getting wrong, you will go back one by one. That also may be advisable. Then induction and then deduction. Induction and deduction la maths la padichirukome. Proof la padipom illaya. So you take a initial step, adukaprom on the loop ku ponga, further steps ku ponga. Deduction appadina that also will be of reverse method. So these are all the various approaches for the debugging. Correcting the error. How do you correct the error? How do you correct the error? Is the cause of bug reproduced in another part of the program? So there is a bug in my one part of the program. Okay. So same kind of error has appeared in other segments also, other modules also. So that is why we can check and then correct it. Or I have a bug, I did not correct it. I think that it's not a very big problem, so let me go along with that itself. But due to that, there is a problem even in other segments. Number 2, what next bug might be introduced by the fix I am about to make? When I am fixing one bug here, there is a bug, I am trying to clear that. I am going to change some other statement, or I am going to remove that, or I am going to do something. When I fix this bug, will it create any other bug in any other segment? Okay, number 1, in the presence of the bug, is there any other bug in other segment? When I fix this bug, will it create some other bug in other segment or other module or other part of the program? What could we have done to prevent this bug in the first place? So these are all the 3 ways to eliminate the errors, remove the errors, correct the errors, right? That's all. We are coming to the end. Think before you act to correct. Use tools to gain additional insight. Before you could correct the errors, correct the mistakes, நம்ம கரெக்டாக பண்ணுறோமான்றதை யோசிச்சு பண்ணணும். Just like that you remove all the statements, then and once again you have to introduce everything. Okay, so இது ஒர்க் அவுட் ஆகுமா ஆகாதா? Use tools to gain additional insight. So you can use some other tools which are existing also to gain more insight about it. If you are attempting pass, get help from someone else. நம்மளால முடியலனா take help from others too. Once you correct the bug, use regression testing to uncover any side effects. This is very important. Always whenever you correct an error, perform regression testing so that the further bugs will be avoided. So I hope with this almost this unit is over. I finished.